depending on the level of whiteness, from black it goes to this one. So if it is say 119, this gray represent 119. So now in the image, what we saw is a white color. This white color, all the pixels in this area will have 255, 250 only. So I can group this. Correct? Identifying pixels having same value. Correct? Yeah, pixel may have 125, or say 120. 120 may be this region. Correct? See, you see the almost, this is looks almost same gray. This gray, this one pixels, all the pixels in this will have 120. So I can grouping. That is called as segmentation. Grouping the pixels having same intensity value. If it is grayscale. For example, take a color image. I can say the red color. That means all these things will red color same value. Correct? Maybe 120. Okay. Green may have some other value, 100. This violet may have 200 within that color. Correct? So in your picture, whether color or grayscale image, if you are able to identify the pixels having same value, correct? Then that is called as segmentation. Okay, that is called as segmentation. That's what grouping a region of image by the pixel with similar properties, that intensity level, color level, whatever it may be. Regions are important for interpreting it because they may corresponding to a object in the scene. Correct? Same. If I talk about this white color, let me clear this. This region is an object. Correct? So it is a white color flower is there. There's a white color flower. Then this is a white color flower. This is a rose color, the red color flower. This is a white color. So if pixels having same property, correct? Same value. That means it represents an object. That's what we want, correct? The whole idea image person to identify object. By doing segmentation itself, sometimes you'll be able to identify objects. Take an object, identify the individual pixels who have same value. That means all this will have 255. This will have 120. This whole area, correct? Please note that it's not whole. Here there's a difference, correct? Here you have a dot. Others it looks like that, but there's a small change, right? So by this you will be able to identify the object, correct? So that is called segmentation. So by doing segmentation itself, many times you'll be able to identify the objects in the scene, because same object having same color or same intensity level, all the pixels have same value. Okay. Thresholding is a method of image region, correct? Method of image region segmentation, correct? How will you do segmentation? Which is called thresholding. Thresholding is called a technique name by which I can segment the image. Okay. From grayscale image, thresholding can be used to create a binary images. Binary means correct, two information. Okay, black color, white color. Here I take an image. This is a frame. In the frame, what I have is an object, a circular object, right? Fully shaded with the black. Okay, this image I call a binary image. Binary means two, right? Bi means two. Binary means two. This is a frame, correct? This is the frame inside which it has a white background and black color image. Okay, this is original image. You wanted to identify inside this frame. Please know that this is the frame taken by the camera. Inside frame, you wanted to find out whether any black color object is there. Right? What you can do is, already it is a grayscale image, correct? It is a grayscale image, but it is only two type of pixels. One is white color pixel. In between gray color pixels are not there. How will you identify? By seeing you are saying, but how the computer will identify? For that, you will use a thresholding. What I doing is, I said thresholding T value. We'll see next picture here in the same slide. T equal to, I said that 150. Okay. If T is called threshold level. If a pixel value is above 150, then all the pixel can be given as same value. Any pixel in this one will be converted into 250 0. Correct? All the pixels in this, inside this circular object will be set as 0. We know that pixels are, we know that sensor, because this is nothing but my sensor, image sensor, in which it has captured. You have dots. The dots represent my pixels or photo transistors. So if light falls on it, it will give 255 value. If light is not falling on it, here it will give 0. Any pixel within this object, 0, 0. Correct? Value will give 0. But other pixels outside this one will give 255. So if I set a threshold value, for example, 150, above that, all the value will be converted to, that means I can identify object. Correct? Even if it is not fully black, partially gray color image, still you can identify. For example, I have a frame like this, inside which I have a square object. Please see that this is not black. It is slightly bluish color. Right? Now, this also is called binary image. Why? Background is white. The object is in blue color, dark blue. How will you identify? I set T value, segmentation, which is called thresholding. Correct? Threshold value is set as, say, 100. We know that blue color, you go here. You can easily find out. The blue, correct? Blue, what is this one? That was this region. It has a higher value, right? 0 to 255. It is converted into, for example, 50, 55. Correct? This region is allowed 50. So what I said is, already color image convert to grayscale. In the grayscale, my any object of blue color will be only have this kind of gray value, 51 or 255. So what I say is, in my this one, thresholding, I set T equal to 55. Right? If value is above 50, any pixel within this will have 55, that you can identify. Then I can mark that. I can identify. So this is called segmentation. You got okay. Thresholding method replaces each pixel in the image with a black color pixel if the value of the pixel is less than some fixed constant called T, where T is called thresholding. Okay. Otherwise, it will be a white pixel. Correct? If the pixel value greater than the thresholding value. So if I want to write a program, correct, C or Fortran or something, what I do? If f x of y is nothing but the pixel, this represents, we know that a two-dimensional image, correct? Pixel is a 2D. Okay, so this is y. So so x value start from 1, 2, 3, 4, like this is 10. So again y, correct? So xy. So if I take this pixel, I say that this is 5, 5. The pixel address. That's what I said. This is 0, 0, first pixel. Second pixel is 0, 1. Third is 0, 2. Generally, in image processing computer, the first pixel starts with 0, not 1. Right? So the first pixel is 0, 0. Its x equal location is 0, y equal 0. Next pixel, x equals 0, y equal to 1. Next one is x equals 0, like this. It goes x equals 0 is the last pixel. Similarly, this pixel is 10, 10. For example, my number of total number of photo cells are 10 in 100 my resolution is 100 pixels. Right? It happens. So by setting this, you will be able to identify the region having same this one. Main thing is how will you identify? You can identify object provided you know the threshold value. What is the value of the threshold you have to set threshold. By using this, you can do segmentation. Thresholding is setting a particular pixel value. If the value is above that, give one fixed value. If value is lesser than all other pixels given, lower value. Okay. There are different type of thresholding methods are there. First one is called histogram shape based. Okay. Which has what you call peaks, valleys, and curvature as a smooth histogram are analyzed for converting image to black and white. We will see what it is. First one method is called histogram shape based. Second one is clustering based, where the grayscale sample are clustered into two parts as the background and foreground of the object. Foreground is an object, background is the scene. Okay. Alternately, can be modeled as a mixture of two Gaussian functions. Just note down the function we are going to explain one by one. The third method is called entropy algorithm. Okay, which uses entropy of the foreground and the background regions and the cross entropy between the original and binary image, except for thresholding given image. So this is third method. Fourth method is object attribute based. Searches and measures the similarity between grayscale level and the binaries image, such as fuzzy shape similarity, edge coincidence, all these things. Please note that this is a separate topic itself. Image processing we teach around 44 hours on full course, right? Image processing and alone, what we talk about. But we are trying to understand what it is as an introductory lecture, because if you want more detail, you have to study more. But here we are trying to understand in 3 to 4 class hour, we want to understand how it works only. Okay. So we are not going to discuss all the methods. We'll discuss 1 or 2 methods only. Then next one is called spatial method. Uses higher order probability distribution or correlation between pixels in thresholding. Last one is called local method. Okay. Adapts the threshold value of each pixel to the local image characteristics. These are many methods because you may come across. These are the more than that, these are widely used methods. Just note down the methods alone. Okay. Then what we are going to see is few of the methods we are going to see. Okay. 1 or 2 methods we'll see how the thresholding can be used for detecting an object. Correct. Thresholding can be used for, which is also called segmentation. Okay. Shall I go to the next slide?
Yes, sir.
Okay. First thing is, we need to what you call automatic thresholding. Okay, automatic thresholding very important because in your autonomous vehicle, your camera takes a picture, a frame, and send the image to your data processing, which is the autonomous controller. The controller has to do all these steps, right? Color to gray conversion, then thresholding, then filtering. Everything should do automatically. Okay, so sometimes the thresholding, the t value in this above equation, the t value you need to set, correct? Suppose manually also you can, and if you want to analyze some pictures, very complex picture, you can send manually also, but you can do automatically also. So that's why you call it automatic thresholding. To make segmentation more robust, thresholding should be automatically selected by the system. Okay, we'll see what is this mean t value. Selecting the t value. Selecting t value has to be made automatic. The knowledge of the objects in the image, in this case, environment. What is that? On the road, you take a picture. You have road on which landmarks are there. There may be vehicles. There may be humans. Correct. There may be bridge. Correct. In your camera frame, you may see a tree. You may see a building. You may see a bridge in front of you. Apart from road, I will show that. So they all you are within your frame. So you need to decide what threshold value should be set, t value, so that particular object can be detected. That can be made automatically. Okay. One is intensity characteristic object. Suppose what are the information needed for setting threshold? What is the intensity of the object within the frame? That should be known. Then size of the object also important parameter. Then the fraction of image that is occupied by the object. Correct? Fraction of image occupied by the object. For example, I have a frame like this. Okay. I am correct, in which there's a road. Okay. There's a tree here in the side. And there's a building here. Side of this one. Okay. This is your car. Correct? So this is a frame cam. Sorry, your car is somewhere here. You have this picture. Camera has captured this picture. Now this is the camera which is on your vehicle, inside your vehicle. It has captured this. Now we know that this road is road end or lane marking, single lane road thing. There's a tree here. There's a tree here. There may be a car in front of you. What something is going in front. All these things are so. What is the area occupied this by object? This object. What is the area occupied by this within this frame? This is my frame. How much area the object occupies in the frame? Similarly, this is a building, correct? Which is seen in this one. That's what we are talking. The third is number of different type of object appear in the image. Please note that in image you will not have same. You are seeing a tree. This is a tree, correct? This is a building. This is road surface. This is a vehicle, right? And apart from that, this is the background. The background, correct, may have something else also. We don't know. That means many different objects will appear inside the frame. So this also matters while setting the thresholding. Okay. How will you choose the threshold value? Right? Choosing threshold using first method called histogram method. Note down in this. Yeah, histogram is a bar graph of a raw data that creates a picture of the data distribution. For example, we have histogram. This is my frame. Correct? A frame captured by my camera. What is there? I have a background which is gray color, on which white color paper is there. For example, think that this is my table. Table is the background. Correct? Gray color lamination is there. This one. And I have white color paper. So I need to identify this white color paper. Correct? By seeing how the computer understands. That's what we are talking about, segmentation. Okay. Now, if I send this frame into a software which finds what is the intensity level, correct? We know that the intensity level varies from 0 to 255 because of grayscale. If it is black means the pixel value. I'm just saying for this one, this pixel value will be 0. If it is if it may have 100, it may have 150, it can have 50, it can have 255. Why? What for you will get 250? White paper. So if you see here, this image or image frame has only two objects. One is the background, other one is the paper. So all this value, all the pixels inside this will have 255. Other pixels outside this 100. Please note that it is not black, it is gray, right? It's slightly whitish. So that's why, for example, it's 100. Any pixel, if you take, right, 0, 0, the first pixel, its value will be 100. The next pixel also will be 100. Now, if I talk here, this pixel will have 100. This pixel will have 100 binary value, but this pixel will have 255. This pixel will have 255. Correct? Now, if I plot, I find the values of the grayscale value of this frame and plot the value. Correct? Then what we will get? The distribution of this will be Gaussian like this. Generally, most of things in nature, if you see, the distribution of any parameter will be Gaussian in nature. Okay. So now I take this one histogram. This is the picture or frame for which I took a histogram. This is the histogram. If I take a histogram, nothing but density value in axis. What is y-axis? Number of pixels having same intensity level. Correct. In this case, you can see that only one pixel. Correct. Frequency appearance only one pixel having 3.75 intensity value. If I talk like this, this is 2 pixels having around 4. You can see that 2 pixels having 4. Then if I talk like that, if I see that 4.25, how many pixels there? around 7 pixels, right? So if I connect that, the bar chart, which is called as a histogram, nothing but it is a bell shape. This is called a Gaussian curve. Okay. Now that you did, what you did? You took a histogram of this frame, got this, right? You take the peak value that you set as a T value, threshold value. If I do that, then what will happen? I will be able to detect, see, any pixel 4.25 will become black. Any pixel whose value greater than, correct, 4.5 will become white. So automatically, please note that this is not pure white, because the image is blurred. Proper lighting is not there. So, but still, I'll be by taking histogram, identifying the threshold value. Here we identify threshold equal to 4.25, right? And then if I substitute that value in this equation, T equal to 4.5, then if I send each and every pixel through this algorithm, automatically I'll be able to detect the white paper by doing what I call as thresholding. This is called as histogram based thresholding. This technique is called as histogram based threshold setting. What is threshold setting? Identifying what is the value you have to set so that I can distinguish two items. This finding a T value, which is called threshold value in the segmentation. For that, you can use histogram method, first method. Okay. So now, so this is the different type of histogram. For this, we took the here this one correction. This is my frame for which this is histogram. This is a histogram for this frame. So you can see that the peak value comes here. There are two values. One is for this. The peak value is around 120 grayscale. For the white paper, please note that this is not pure white, right? Slightly grayish, correct? So for the histogram value for this is, you can see that something around 210, something like this, right? You are getting two threshold values. Okay. Now what you can do is you can use any one of the threshold value, so that you will be able to, in this formula, which formula, this formula, then automatically you'll be able to identify this white paper on the gray background of the table. Okay. Sometimes, for example, here you have only one object. Whatever you have only one white color paper and a gray color table. So easy. Okay. But sometimes you have multiple objects in the frame. You can see that one rectangular grays color paper, one square grays color, right? This is gray color square object. This is gray color rectangle object, and a black color round object. They are all lying on a slightly gray table. So have 4 different type of table background, then this object, then the second object, then this is third object. 1, 2, 3, and this is 4. Okay. Now 4 objects are. How will you want to know what are different objects? So then you have to go multi-level thresholding. What do you do? You set multi-level thresholding. So this is the algorithm or pseudo code. You have to find what to be for each this one. You can see that if this is pixel location, we know that this is first pixel, second, third, fourth, like this. First row, second row, 1, 2, 3, third row, like that. It is there. Now take the first pixel and verify whether what is the threshold. First thing is this image will be passed to you will do the histogram analysis. What you will do? You do histogram analysis, so that you will get, this is a histogram. For this object, this is histogram. You see that there are 3 distribution. Okay. So you find out the peak value. the center point. And this I call T1, this I call T2, this I